All right, so continuing with verifying the identity. Again, we're going to start with the more complicated side. So for problem 3, we're going to work on simplifying this side until it turns into cosecant squared theta. So I'm going to start by rewriting this using the reciprocal. So this will be 1 plus 1 over sine squared theta, and then times cosine squared theta. And I'm going to multiply straight across. So 1 plus cosine squared theta over sine squared theta. And then I'm going to use the quotient identity to rewrite this term as cotangent squared. So 1 plus cotangent squared theta. And that reminds me of a Pythagorean identity, so I'm just going to check my cheat sheet here. And it looks like it's going to match this one. So that means that I can replace it with the cosecant squared theta. And now my two sides match. So again, we were hoping to get this, and we did. So we verified the identity. Next one. So again, I'm going to start on this side. It's the more complicated side. And as I'm looking at this, I'm noticing that cotangent is in both of these terms, and I'm dealing with squares. So this is a case where I'm definitely going to want to try to factor. So I'm going to factor out cotangent squared theta from both. So in this term, since I'm taking it away, I'm left with 1. And then when I take it away from this term, I am left with cosine squared theta. Now remember to check if you factored correctly. If you distribute this back in, you should have this exact same thing at the top. Okay. Now looking at this reminds me of the Pythagorean identity. So that top one, if we subtract cosine squared over, we would be left with sine squared. So I'm going to replace that next. So this will be cotangent squared theta times sine squared theta. And then I'm going to use the quotient rule to rewrite cotangent. So this will be cosine squared theta over sine squared theta, and then times sine squared theta, which means that these two are going to cancel each other out. And I am left with cosine squared theta. So again, I just found this part. So I have verified that the identity is true. Now keep in mind, we could get a no solution answer, but with these practice problems, they should all be able to be verified. But it is possible to get a no solution. Okay. All right, let's do the next one. So I'm going to make them a little bit more complicated now. So I would like you to pause the video and see if you can try and figure out either 5 or 6. All right, so looking at problem 5, again, the more complicated side is going to be this side right here. So that's the part that I am going to focus on. Now this looks really close to a Pythagorean identity, but it's missing the squared. So what I'm going to do is I'm going to multiply. I'm going to rewrite this just to give myself a little bit more room. So we'll still have that sine squared theta over 1 minus cosine theta. And then what I'm going to do is I'm going to multiply the top and bottom by this conjugate. And that's going to help me create a perfect square down in the bottom. So I'm going to multiply by 1 plus cosine theta. And then I have to do the same thing to the top. So I'm going to wait to distribute just to kind of see what happens. So sine squared theta times 1 plus cosine theta. And then if we FOIL the denominator, so that will be 1, and then I'll have plus cosine theta and then minus cosine theta. And then negative cosine theta times cosine theta is negative cosine squared theta. So what's going to happen is that these middle terms are going to cancel. And again, I'm going to wait to distribute. Okay. So the top's going to stay the same. So sine squared theta times 1 plus cosine theta. And part of the reason why I'm waiting to distribute is because this matches what I'm trying to get through. So it's important that we kind of notice those things and we're thinking ahead in our steps. And then this will simplify to be 1 minus cosine squared theta. So now I have one of the Pythagorean identities. So if I rearrange this one by subtracting that cosine squared over, then I can replace the denominator with sine squared. Okay, so numerator is the same. So sine squared theta times 1 plus cosine theta over sine squared theta. Now, because we have multiplication in the numerator, where we're taking sine squared theta times this group, I'm allowed to simplify the fraction. So that means that these sine squareds are going to cancel each other out, and I'm going to be left with 1 plus cosine theta, which is what we were trying to get to. So I have just verified the identity. All right, so again, I want you to try number 6, and then I will do that in the next video.